Welcome to the jungle. Thank you for joining. Once again, I'm your host, Gringo Kurt. If you've seen previous episodes, then you know that we've got a lot of history to learn, so I'll keep this intro short. This is the timeline. This is when the Earth and the Moon were formed. And this is where we left off. So, let's get into it. Now let's look at some different evidence that was also recently researched and then published, and also dates back as far as the Hadean Eon. To do this, we must learn about a fascinating story that takes place on the opposite side of the globe. And this story is so incredible that most will be shocked that they have not at least heard about it. The story that I'm about to tell is based on true events. Please meet Dr. Papineau. I'll give him a better introduction later, but for now, as we begin the story, Dr. Papineau is a Canadian eager to find the earliest evidence of Earthlings. The first thing he did was to come up with a few qualifiers for places to search. Now, back in 2008, it was already well established that abiogenesis occurred somewhere around oceanic hydrothermal vents. So, that began the list. Next, he added that it needed to be old enough and that it needed to be accessible. This was a short list, but still not an easy one to complete. After doing plenty of research, he found a spot that qualified, and lucky for him, it was even located inside the borders of his home country. So, he decided to check it out. No longer a chunk of the seafloor, the Nuvvuagittuq Supracrustal Belt contains some of the oldest rocks that exist above water. When Dr. Papineau first visited the site, it had already been dated to over 3.8 billion years old. This age was established during the examination of approximately 20 zircons. Along this supracrustal belt, there's evidence of rocks being cooled, reheated, and stretched again and again. To understand why theories proclaim that the Nuvvuagittuq Supracrustal Belt was an ancient hydrothermal venting system, we'll need to study geological maps such as this one. The color white is used to identify the surrounding area as ancient seafloor bedrock, and I've added some geology notes about it over here. But the other colored zones represent varieties of igneous rocks, aka cooled molten magma. The few pink bits show us where pegmatite rocks are located. This is theoretically where the area's most recently active hydrothermal vents were functioning. Chemical sediments are solid materials formed by the precipitation of dissolved chemicals from early Earth's ocean. What's known as banded iron formations likely formed as a result of when our early atmosphere and oceans possessed high levels of dissolved iron. Under these conditions, iron-rich minerals precipitated, forming layers on the ocean floor. These layers could have been deposited cyclically over time due to variations in factors like ocean chemistry, climate, and possibly even biological activity. The grayish bits represent gabbroic intrusions, aka locations where slow-cooled magma from deep inside a volcano solidified below the elevation of the surrounding bedrock. When researching gabbroic intrusions, you'll find that they're also known as mafic sills. The large, light green portions in the map indicate mafic metavolcanic rocks. These rocks show signs of metamorphism, likely from being heated and stretched under extreme pressures. And lastly, there are ultramafic rocks located in the few dark green regions. These are igneous rocks that have been crystallized. Their mineral composition is distinct from the other igneous rocks due to the specific conditions from which they were formed. There doesn't seem to be a singular radius from where the lava came from. Instead, it radiates from multiple breaks within this area of oceanic bedrock. Remembering back to our timeline, the crust was very young when these described events occurred, so it was likely not as thick as it is now. It would seem that something caused it to swell and break in at least two major locations. Afterward, the lava that rose to heal the wound repeatedly cooled and partially melted the remaining rubble. Some of the gaps from within the ancient rubble formed into systems of hydrothermal vents. Chemical reactions became constant in and around the hydrothermal vents, and though the venting was consistent, the minerals being vented out did not always possess the same ratios of elemental particles. Sometimes there were more of these elements, and sometimes there were more of those, and sometimes there was even a little of something else added to the mixture. Anyway, the point is that the ever-changing mineral ratios complicated the environments in which such chemical reactions were occurring. These complications, or obstacles, caused the chemical reactions to either adapt to their ever-changing environments or to stop existing entirely. Those that most successfully adapted to the broadest variety of mineral intake outcompeted those that were less adaptable. As time passed, they hypothetically became less and less finicky about the types of minerals that they were being fueled with. The circulations within hydrothermal vents may have theoretically decreased until eventually the chemical reactions surrounding them had evolved to become less reliant on the minerals that they had previously offered. Some of these deprived chemical reactions evolved to utilize other energy sources. To date, it seems that sunlight was likely the earliest type of fuel that granted liberty for them to progressively venture away from their hydrothermally vented needs. Well, I'm about a liposphere away from repeating what I said during episode 1, so if you'd like to learn more about abiogenesis, evolution, or the importance of margin for error in self-replicating molecules, I encourage you to check it out. The focus of this episode is to paint a memorable picture of the type of environment in which these happenings likely occurred. So yeah, the Nuvvuagittuq Supracrustal Belt was Dr. Papineau's version of striking gold, because his checklist was now complete. And this is when he called up some of his associates saying, "Hey guys, I need a few men with a particular set of skills. I'm searching for evidence of the earliest Earthlings, and I need some experts. So, you want to come out and play?" Well, he probably said something more elegantly convincing than that, but what's important is that they all agreed, and they all convened in Canada. Dr. Papineau took the guys on a hike and showed them around. He explained that the location was rich with evidence suggesting that they were standing on what was long ago a hydrothermal venting system. During the taking of this picture, he told them that the orange-colored iron carbonate on this rock may once have been part of a hydrothermal vent system miles underwater. Later, he said, here's a jasper-banded iron formation with gray magnetite layers and red hematite-rich silica layers, both being iron oxide minerals. But the black spots, they're just lichens. Obviously, they're still alive and therefore not part of the tour. Here, we have an outcrop with iron carbonate, referring to the orange and black bits, and we have some white and gray concretions, which contain carbonate apatite rosettes. Interestingly, these same mineral ingredients are found in bones. When these formed 3.7 billion years ago, there was microbial organic matter present. In this one, a layer of red silica rock is bonded by veins of white calcite, which have sourced some of their carbon from decayed, primitive microbes. Next, we have this banded iron formation, possessing convoluted layers of light gray quartz and dark gray magnetite. Both layers are a bit thinner than a Canadian penny. Dr. Papineau went into lots of details throughout the hike, and by the end, they were all impressively convinced that this location was indeed a hydrothermal venting system of the oldest variety and accessible. The team's next step was to search for evidence of biology, so they organized their best plan of action, and then they got to work. In 2017, they authored a published article detailing their 2008 discoveries of microscopic tubes and filaments. Evidence from the work suggests that forms of iron-loving bacteria had created them. Here are some of the details within it. To be technical, this image is of a microscopic form known as a carbonate apatite rosette. In this example, the iron carbonate bits are white, and the gray bits make up the concentric layers of quartz inclusions. Its core is a single quartz crystal with nanoscopic inclusions of red hematite. These may have formed through the oxidation of organic matter derived from microbes living around vents. A carbonate apatite rosette is a collection of minerals shaped similarly to a rose blossom. Dr. Papineau says that they are biologically created remains of pre-existing bacteria. Like others that existed around it, this was once home to a web of ancient microscopic bacterial ecosystems. Bacteria caused changes to their environment, and those changes were fossilized for us to study today. Let's compare this carbonate apatite rosette to something within our scale of reality. Let's say that humans somehow went extinct. Now, imagine aliens looking around and saying, if there were no humans, then how the hell did all these cities get here? The cities in this scenario are what's scientifically known as trace evidence. If aliens could not find a skull, a femur, or even a tooth, they'd still think that life existed on Earth. The reason for thinking this would be based on the fact that cities do not naturally occur. Well, neither do carbonate apatite rosettes. When a photo is taken of a thin slice that has been cut from a rock containing carbonate apatite rosettes, it looks like this. As you can see, these microphotographs visually resemble the other microphotographs, labeled Loken. Loken refers to samples gathered from around Jan Mayen Island. Those samples are then analyzed in Lokenberg, which is a village near the city of Trondheim, Norway. Because of the numerous deep-sea venting systems that are located somewhat near the vicinity of Norway, laboratories in Trondheim have been especially suited for performing hydrothermal vent research. Though uninhabited, Jan Mayen Island is famous for its adventurous research expeditions to Loki's Castle. Discovered in 2008, Loki's Castle is a field of 5 hydrothermal vents that have been active for the past 10,000 years. With lots of history still waiting to be discovered, this location has been the subject of scientific research aimed at understanding deep-sea hydrothermal vent ecosystems and their role in supporting unique forms of life that thrive under extreme conditions. So, examples that are labeled Loken can be recognized as being the youngest possible recorded comparables utilized by Dr. Papineau. In this image, we can recognize that after billions of years, similar forms of Earthlings persisted. In this image, we can also see rosette examples of NSB or Nuvvuagittuq Supracrustal Belt being compared to microphotographs of samples labeled Loken, but there are also other example images labeled Brockman. Examples labeled Brockman refer to the Brockman Iron Formation. Interestingly, similar trace biological pieces of evidence have also been discovered here. The samples studied here date to approximately 3.48 billion years ago, and they also originated around hydrothermal venting activity. The Brockman-labeled images are of banded iron formation hosted microfossils from the Dresser Formation within the Brockman Iron Formation of Western Australia. These images were published by Nuvvuagittuq. The paper was published in the journal Nature on May 9, 2017. Recognizing that Tara's article was published only a couple of months after Dr. Papineau's highlights that these studies were likely being conducted side by side, and we can see that they were sharing their findings to better the overall success of both projects. Once again, just another example of people helping people within the world of research. This image compares the nearly identical mineralogy that all 3 rosette-shaped examples possess. It also puts evidence in the rock record, showing that these similar forms of bacteria were already widespread prior to 3.5 billion years ago. Carl Sagan is attributed with saying, "Extraordinary claims require extraordinary evidence." Well, most in the scientific community were convinced that Dr. Papineau and his team had pulled it off. There were, however, a few who remained skeptical, and Dr. Papineau was not okay with that. He was certain that his team could convince them all that the origin of these structures was biological. The publication was a tremendous success. Most had doubted that it would be so convincing. Nonetheless, Dr. Papineau wanted everyone to recognize the nature of reality better. Now, he was even more seriously motivated than ever before. So, he shaved off his beard, acquired some better equipment, then he and his team returned to their findings and got back to work. Afterward, their additional efforts were published in April of 2022. To begin with, they recognizably upped their game in the microphotography department. From a distance, the photographic advancement isn't easily recognizable. However, once you look closer, these images possess much better quality in terms of depth. They reveal microhabitats, often occupied by oddly grouped spheroidal shapes, all seemingly frozen in time. In their studies, the team used micro-CT and ion beam techniques. They were able to process thicker sliced rock samples, and they developed a specialized technique of stacking images. They found modern-day equivalents to the twisting filaments, parallel branching structures, and distorted spheres. The scientists confirmed the hematite filaments were wavy and twisted and contained organic carbon, which are characteristics shared with modern-day iron-eating microbes. But first, they began looking for supporting evidence in chemistry labs. The team presented these photos of biomimetic experimentations. In other words, these are the end result photos of laboratory-generated methods of placing the correct abiotic chemistry into properly measured environments and predicting that the outcome effects will mimic particular biochemical processes. All of these photos seem to resemble known biochemical processes, and for that, their work has been regarded highly. Now, if these chemical reactions were able to generationally mutate and evolve, then they'd fit episode 1's definition of life. These images prove that scholars generally understand how to mimic biochemical processes. They know what needs to be included or excluded from an environment for such non-geological instances to occur. In this next set of samples, images on the left are microfossils of ancient but not so ancient past. As you can see, they are much better preserved. Not only do the older versions visibly resemble more recently fossilized versions, but notably, they're also mineralogically identical. Here, as previously mentioned, example A is suggested to be a relatively recent version of the Nuvvuagittuq Supracrustal Belt example E, as it originated around the presently active hydrothermal vent system of Loki's castle. And here, example B is suggested to be a less ancient version of the Nuvvuagittuq Supracrustal Belt example, located to its right. This magnificent comparison originated from the east of Madagascar and below the Indian Ocean. Lastly here, we recognize that sample C is being compared to the much older example to its right. And we see that example D is a presently surviving representation of the microfossil photographed in example C. These images are of spheroidal and irregular ellipsoidal microfossils from the rock record. They have comparable morphology, size, and composition to NSB irregular ellipsoids. In section A, we have the Strelly Pool Formation. Remembering back to the team's 2017 publishing, they labeled examples from this site as Brockman. Well, now, in this new publishing, the team has decided to label examples from this Western Australian research site as Strelly Pool Formation. Moving onward, we adjust our focus towards evidence labeled B. Here, we come to the Nuvvuagittuq group. Remembering that the Brockman, aka Strelly Pool Formation, produces microfossils dating to 3.49 billion years ago, Nuvvuagittuq will be the only location to produce comparable examples that are even older. To be more precise, the possibly 3.6 billion-year-old Nuvvuagittuq group microfossils were gathered from the Barberton Greenstone Belt, which is located on the border of Eswatini and South Africa. The microfossils gathered from the Buxa Formation originated from the location in the Buxa Hill region, West Bengal, India. This site possesses earthling evidence dating back to 2.5 billion years ago. And lastly, named after a city in Minnesota, the Biwabik Formation possesses representational evidence of Earthlings dating back to 1.9 billion years ago. Together, these pieces of evidence also solidify the theory that Earthlings have existed before the most traumatic portions of late heavy bombardment period. Once again recognizing the difficulty of attempting to comprehend how much time a billion years is, we'll return to our timeline for a more conceivable perspective. We can see here that the locations that Dr. Papineau and his team chose to study evenly span the spectrum of Earth's timeline. They also spread their research fairly evenly across the globe as well. Before Dr. Papineau's work was published, scholars were already teaching students that Earthlings have existed for 3.6 billion years. And, as of 2022, we have scientifically recognized microfossils being studied that stretch into the Hadean Eon. Personally, I understand why many think that geology is boring, but this historical discovery literally changes the age of Earthling existence. And not by a little either. The answers that they have found thus far tell professors that they must now reset their earliest Earthling lectures backward in time by roughly 500 million years. Now they will need to explain Earth, during our Earthling origin story, as a place that was still forming its crust and headed toward an era of extremely heavy bombardment. This description is what we should think of when Earthlings first started producing history for us to find. This last set of images are bacterioforms that have been speciated. These species morphologically resemble examples gathered from the NSB, plus they're also involved in iron cycling. It seems logical to compare Nuvvuagittuq Supracrustal Belt images to other images that are both similar and already known about. Since the publication of Dr. Papineau and his team's work in 2022, the International Union of Geological Sciences, the IUGS, included the Hadean Eon within their description of the Nuvvuagittuq Greenstone Belt listing. This listing includes the belt among an assemblage of 100 geological heritage sites around the world. So now, Dr. Papineau and his team are world-renowned, and so it's probably time to properly introduce him. Dr. Dominic Papineau is a paleontologist at China University of Geosciences, the London Center for Nanotechnology, the Department of Earth Sciences, and the Center for Planetary Sciences at University College London and Birkbeck College London. Perhaps I should have listed his credentials earlier, but yeah. Dr. Papineau's proper introduction produces the image of a person who knows stuff. So, let's get some quotes. He stated, using many different lines of evidence, our study strongly suggests a number of different types of bacteria existed on Earth between 3.75 and 4.28 billion years ago. He also said, this means life could have begun as little as 300 million years after Earth formed. In geological terms, this is quick, about one spin of the Sun around the Milky Way galaxy. And that, if life is relatively quick to emerge, given the right conditions, this increases the chance that life exists on other planets. We found the filaments and tubes inside centimeter-sized structures called concretions or nodules, as well as other tiny spheroidal structures called rosettes and granules, all of which we think are the products of putrefaction. The structures are composed of minerals expected to form from putrefaction, and have been well documented throughout the geological record from the beginning until today. The fact we unearthed them from one of the oldest known rock formations suggests we have found direct evidence of one of Earth's oldest life forms. This discovery helps to piece together the history of our planet and the remarkable life on it, and will help to identify traces of life elsewhere in the universe.